Welcome to the video. Today we are going to solve another Math Olympiad problem, which is on series. Okay, so let us follow our plasma method. So P stands for problem understanding. So let's look at the problem. So we have to calculate this expression, which is half times 2019 multiplied by 2018 minus 2018 multiplied by 2017 plus 2017 multiplied by 2016 minus 2016 multiplied by 2015 plus all the way up to 3 multiplied by 2 minus 2 multiplied by 1. Okay, so what we are looking at here is all the odd multiplied by even is all pluses, and the even multiplied by odd is all negatives. Okay, so far that's what we understand here. So this is how the series has come from all the way from 2019 to 2 into 1. Okay, then linking of concepts. So this is a series problem. A lot of times we have seen the series problem in the fraction where there is a multiple, a multiplied by b uh, in the denominator, and then we evaluate by doing b minus a upon a multiplied by b, right? So this is what we have seen a few times in my previous videos, but there is no fraction, there is no denominator here, so it's all in the numerator. So how do we solve this kind of a problem? So this is a series problem where we have to find a way to somehow make it either an arithmetic series or a geometric series, right? Because you can see plus minus here or you can see multiplication here. So those are the concepts. Basically, that's what we're going to use. In terms of assumptions, there is no assumptions here to check. Then we have to go for solution step by step. So let's get into the video. Okay. So what we know so far here is, if you look at this expression, what you see is there is this common in both of these terms next to each other. Here also you see that this is the most common term. Here you're seeing this is the common term. Actually, I've written it this way, but in the actual Olympiad paper, this is all in one line. So it's a little bit tricky to pinpoint how to take what factors to take out. So, we know that there is a difference of 1 here, there is a difference of 1 here. But if we take out this factor, then the difference becomes 2, right? The same thing, if we take out this factor, the difference becomes 2. If we take out this factor, the difference becomes 2. So this is kind of the key here to solve this kind of a series problem. Okay, so eventually what we're looking at is it will be half times 2018 multiplied by 2019 minus 2017 plus, now this plus comes, then 2016 times 2017 minus 2015 plus, and this will go up to 4 times 5 minus 3 plus 2 times 3 minus 1. So all these dots are actually the multiplication. These are the fractions taken out. So what we're seeing now is all these is basically the difference is 2. So if we take out this difference, so this will look like 2 is taken out, so it will become 2 divided by 2. So that's why this will cancel out. And what we are left with is 2018 plus 2016 plus 2014, because it's all going 2 less, and then plus 4 plus 2. Okay. So what is this? So this is a arithmetic series. Okay. So I mean nothing now. Most of it is already there. Now we just fraction out 2. So this will go from, if we write from here, this will be 1 plus 2 plus 3 plus up to 2014 will become 1007, 2016 will become 1008, and 2018 will become 1009. So this series will give us arithmetic series sum is n into n plus 1 by 2, which is 1009 multiplied by 1010 divided by 2, and we know there is already a 2 here. So 1009 multiplied by 1010, that's our answer. Okay. So so basically sometimes the series can get a little tricky, and we have to just find out how do we solve, what is the factorization that you can do, just to simplify it as much as you can. Okay, so this is our answer, final answer. Let me get into another, let me give you another trick for another question. If 1, 2, 3, A, B, C, 7, 8, 9 is divisible by 999, we have to find A plus B plus C. Okay. So in terms of our plasma method, what is the concept that we are looking at here is the number theory divisibility concept. So this is a number theory divisibility concept. Okay. So 999 can be factored into 9 times 111. This 111 is divisible by 3, which can be further factored into 3 times 37. Okay. So there are two ways to approach this. So what number is divisible by 9? When all this sum of each of the individual digits is divisible by 9. Which number is divisible by 3? Again, when all the sum of the digits is divisible by 3. And which number is divisible by 37? That's where it gets interesting. So the funda or the concept that we are using for 37 is the same concept that is used for 999 also. So the divisibility by 999 is very similar to the divisibility by 37, and that is for any number n, we have to break it into the groups of 3. Then this is another group of 3, then group of 3. So let's say this is A, this is B, this is C. So we have to sum A plus B plus C. And if this is divisible by 999, if this is sum is divisible by 999, then we can say that this number is also divisible by 9. So that's the key concept to learn. Let me repeat. So anything which is so for any big number, you divide it into groups of 3. So like here 7, 8, 9 is a group, ABC is a group, and 1, 2, 3, these are 3 groups that you can identify from here. And then if you add all these up, it should be divisible by 999. If that is true, then this number will also be divisible by 999. Okay, it's the same concept for 37 as well, that if these 3 you add them up, but in 37 what you can do is you can keep on doing the same thing over and over again. So if this number plus this number plus this number is divisible by you get let's say a 6-digit number, a 4-digit number, you can again do a 3 and a 1 and you can get a 3-digit number. So, and finally you can check whether that is divisible by 37. Okay, let's come to this problem. So the problem is if 1, 2, 3, A, B, C, 7, 8, 9. So we divide into three groups, 1, 2, 3. So let's add these three groups up. So 789 plus 123 plus ABC. Now we don't know what ABC is. So let's just add these two first. Okay. We add this later. So 9 plus 3 is 12. 8 plus 2 plus 1 is 11. 7 plus 8 plus 9 is 912. And then we have to add ABC into 912 such that this whole number is divisible by 999. So the maximum value that ABC can take is 999 and the minimum value it can take is 001. So but which number will be divisible by 999 here? When it is actually 999, right? This cannot be lower than, so ABC will be between 001 and 999. So 912 plus ABC can only be 999. This is the only solution. So this gives that ABC will be 999 minus 912, which is 87. And then this will be 0. So this means that this is 0, this is 8, and this is 7. So the question we are asked is, what is the value of A plus B plus C? So A plus B plus C is 8 plus 7 is equal to 15. And that's our answer. So we learned some concepts here about number theory, and the previous one was on series. Keep watching, keep learning, and hope you like this video.